Okay, so this is a quick video recapping the particle model. A lot of this you will know from Key Stage 3. There are three main states of matter that we need to know about at GCSE, and they are solid, liquid and gas. Now, in solids, the particles are arranged in a regular fixed pattern. They are touching. Sorry for my circles that are not all the same size, but hopefully we can get the idea here that they are in a regular fixed pattern. Okay, the particles are in contact, and the particles don't particularly move around at all, but they do vibrate. Now we can say that there are strong intermolecular forces between them. I say bonds, but apparently in chemistry you shouldn't say that. And a solid has usually got a high density because there's lots of particles squashed in together, and it has a fixed volume and a fixed shape. So the facts to know about solid: regular fixed pattern, the particles are in contact, they vibrate, they don't move around, but they do move. They have strong intermolecular forces, also known to some people like me as bonds. They have a high density because the particles are packed together, and they have a fixed volume and a fixed shape. Then we go to a liquid. Now, my biggest bugbear is when people draw liquids like this. This is not a liquid, okay? In a liquid, I've made myself a rod here to use my own back because I've made these particles too small. They should be the same size particles as here, but hopefully you can see that the particles are still touching. The only difference is that now they're not in a regular pattern, okay? So the particles are free to move. They usually slide over each other, but they are still in contact, okay? They're not far apart, and they don't vibrate now, they now move around that way. We had before there were strong intermolecular forces. We've got weaker forces than before, or weaker bonds, you might say, if you may. So weaker intermolecular forces in solids, but they're still quite strong. They're only we break about 1 in 10 bonds, or we decrease the forces by about 10% as we go from solid to liquid. It's not a lot. Now, other things to think about in terms of density, volume and fixed shape. Generally, they're a lower density slightly because they're a little tiny bit further apart. Yes, they're in contact, but they're a little bit further apart. An exception to that is water. Water, no, that's wrong. Ignore me. It's the next bit that's different. Water is funny because it increases its volume when you freeze it, and that's unusual. But however, they still have a fixed volume. Slightly lower density, but not much. Fixed volume, but no fixed shape. So they fill the container, or they take the shape, I should say, of container. So if you've got 100 ml of liquid, whatever container it's in, you've still got 100 ml, but they will take the shape at the bottom of that container. And then we move on to gases. And gases are more like this, and often people will draw little lines in them to show that they are whizzing about. So gases are free to move, and we often say that they move in rapid random motion. Now they actually travel in straight lines, but they travel in a straight line until they hit something, and they bounce and hit something else, and they bounce and hit something else, and it carries on like so. So it looks pretty random. They're not in contact, so they're not touching. And there are very weak forces between them. When you get to A level, you essentially decide that there are no forces between them, which is not completely true, but it helps with calculations. They have no fixed volume. They take the volume of the container. So if you have a small bit of gas and put it into a room, they will fill up the volume of the room. And also they have no fixed shape because they fill the container. And the final one, you can see this here, hopefully, they have a much lower density. And it's much lower, like the difference between a solid to liquid is quite small in the density, but liquid to gas is a big difference in terms of its density. Now you do need to know the names of the transitions between these states, and people often confuse themselves with this. So think about ice. If you've got or water, so ice, that then turns into liquid water, you would say that it melts. So this is melting. So from a solid to a liquid is melting. And then if you've got liquid water and you want to turn it into steam, people like to say evaporation. That is like a special case. If I want to turn all my water into steam, I wouldn't just let it evaporate. I would use a kettle and I would boil it. So boiling is the word here. Now, if I've got steam and it turns back to liquid water, maybe in the kitchen it hits the window, that is called condensation or condensing. And then when I take liquid water and want to turn it into ice, that is called freezing. So they're just normal words. These two words are a bit more different. They're not used as often. If you can go straight from a solid to a gas, it happens more with things like dry ice or carbon dioxide. Going straight from a solid to a gas is called sublimation. And then going from a gas to a solid is called deposition. It's rare, but it can happen. So you need to know those words. The final thing to kind of talk about is what happens, what increases as you move up the states. And there's more than one answer here. Now, the hopefully obvious one is that to get from solid to liquid to gas, you have to increase temperature. But the important thing is what that means. An increase in temperature means you're increasing the average kinetic energy of the particles, because that's what temperature is. Temperature is a measure of the average Ke of particles. So as the solid becomes a liquid, we have to heat it up, and then liquid to a gas, we keep on heating it up. So it increases the temperature, and that causes their average Ke to increase. And think about it. The solid is just vibrating. It has got Ke because it's moving, but it's vibrating. And the liquid's moving over each other, and it's got a bit more Ke. And then the gas is whizzing around, so it has a lot more kinetic energy. So that's the kind of main stuff that you need to know about particle model. Hopefully that was useful.